right now is how this shelf and these partitions are installed in the cabinet. Eventually these are drawer pockets, so there'll be drawers, 3 drawers in this cabinet. And first I'm going to go ahead and take this apart so you can see. Well, first I'll slide these out. These are slid in from the back, and they're held in place with a loose spline. So there's a groove in the cabinet and in the bottom of the shelf here that this slides into. And then this shelf slides out the same way. So there's a groove in the side here, and there's a groove in the end of the shelf. The reason we do that is so that I can fit it perfectly. Once the cabinet's glued up, I'm going to be pushing this in from the back before the back goes on. And as I spoke about in the last video, we want the back of the cabinet to be slightly wider than the front of the cabinet so that the drawers move easily and stop just as they get to the end of their run. So in that case, the ends of the shelf are going to be actually beveled. They're going to be angled, so it's narrower in the front than it is in the back. It slides in from the back and tightens as it gets in. That means that I'll be able to fit it afterwards and fit it perfectly, and then I attach the splines. Now if this was a rabbet joint, or if this had a shoulder on it, I'd have to use a rabbet plane to fit this into the cabinet, which would be a lot more difficult. So this is just a simpler way to do it. So the way that these slots are made is I made a router jig. That sits on the bottom of the cabinet, and it lines up with the sides. And I come in with a template follower and route the grooves. Then this same template is used on the bottom of the shelf to make the same grooves. You want to make sure that when you're taking the template from here to here, you don't go like this. Because if there's any discrepancy in these sizes, if you flip it over, it doubles the mistake. And then you end up with partitions that are at an angle. Okay. So that is the jig that's used for that. And then the other jig we use is for the sides. This is a piece of 1/4 inch masonite. I use the hard masonite for this because it'll hold its shape better than the soft. And this also has holes drilled in it for my shelf supports. This gets attached to the side. I'm using double stick tape here to hold it in place, and then I actually put a clamp on it just to make sure that it doesn't slip around. So this is drilled on the drill press for the holes, and again the router is used with the template follower to route these small dados. I get a Forstner bit that's the same size as the template follower. In this case it's a 3/8, and I drill a hole on the drill press out at this end. Then with a square I draw pencil lines, and you can either remove the waste with a bandsaw and then file it to straight. You've got to make sure that when you're filing, that you file it really super evenly so that you don't have any movement back and forth. It slides easily, but it doesn't move back and forth. The other way I've done this is on the table saw. You cut in with a crosscut, the miter gauge on the table saw as far as you can go, and then finish it with a hand saw. That leads me to this jig, which is made the same way, which is my jig for the hinges. Okay, now I'm talking about, these are knife hinges that will be invisible. The only part you see of the hinge is just this tip here sticking out of the door. So they're really nice. They don't take away from the design too much. You have to use a knife hinge when the door is set into the cabinet so that it can open up all the way around. See? And the way that the hinges are installed is, first I get the hinge, and they're over here. These are a Brusso type hinge. They're really well machined. The first thing I do when I get these is I file the hinge itself. I file a slight bevel on the hinge. And the reason for that is I want the top of the hinge to be slightly wider than the bottom. Now I'm talking 1 or 2 degree angle, a tiny angle. Then once that's filed, I take the hinges and I've placed them where they're going to be. I've got my doors right here. This is going to be sitting just like that. I don't know if you can see this, Keith. The side is here. The door will be right there, so you'll only see this tiny part of the hinge. I want to place my hinges with the sides in place. I go ahead and I drill the holes where the screws are going to go, and I put screws in. Now the screws I'm using here are steel. When I do the hinges, when I do all the placing of the hinges, I use a steel screw, because the brass screws that come with the hinges, if you put them in, take them out, put them in, take them out, they disintegrate. So you just save the brass screws for the very end. We use this same size steel screw to do all our fittings. I put these screws in, then I take an X-Acto knife and I go around the edge and cut through the surface of the wood. Now this is why the bevel was done, because the bevel, if I did this without the bevel and made the line, when I finished the mortise, you'd see the line. It would be an X-Acto knife thickness away. So the bevel gives you an exact fit. If I just took this hinge right out of the package and put it on and made a line around it, when I mortised out everything and set the hinge down in, the line would be just slightly outside the perimeter of the hinge because of the thickness of whatever my marking tool is. If you used a pencil, it would be even worse because the pencil. So since I'm using an X-Acto, that minimizes it. But still, you would see those lines. So once that's done, then I can take the screws off, take the hinges out, and I go around the perimeter of the line I just made with the X-Acto knife, and about a 32nd of an inch inside of it, I chisel down and cut through the fibers. I don't want to do that right on the line because, of course, the chisel has a bevel on one side, and when you hit it, it wants to move that way. So you do it just inside the line so that when you hit it, it moves over to the line. Once that's done, and I have my perimeter established, since these hinges have a round section, I can't use a square chisel. So what I've done is I took a gouge and I filed it the opposite of the way you'd regularly sharpen a gouge, so that the outside is flat and the inside is beveled. And these go right to establish, hit with a hammer, those establish the curve for the mortise. Okay, so once I've established that line, then I take my jig that I've made, and I made it in the same way that I made the other jig, with the Forstner bit that's this size, and cut it out with a scroll saw, and then filed it to fit so that my template moves in there easily. The reason this is so asymmetrical is when you put it over where you're going to be routing, you need to have enough room over here to put 2 clamps that won't get in the way of the router. You want to use a plunge router for this operation. That gets set right over there and then plunges down in. There we go, plunges down in. You set the depth. The reason I route out the waste in this case is because it's really hard for me with chisels to make a flat bottom mortise. So the router just gives me that flat bottom. And then once it's routed out, I take my chisels back in and I clean up those edges, and the chips will fall in, and then it can be flat bottom. The reason I use the chisels before I use the router is because it gives me a much cleaner cut. I'm cutting through the fibers on the surface so that the router is not going to tear out the wood. Then when I have to make a separate jig for the doors are going to have a different jig, which is shaped like this. It's the same shape, it has a fence on it, but I need to be able to clamp this to the top of the door. So this piece of wood allows me to clamp to the door, and then I can do the same operation here. which I'm not ready to do yet because I have to finish the cabinet before I know exactly how tall the doors are going to be. When I mortise the doors, I will be using chisels to establish a perimeter, the same method. And it is, since it's end grain, it does route differently than the side grain. With end grain, unless your chisels are super, super sharp, it's hard to get a flat bottom mortise, especially in this wood, which I've discovered it dents just by looking at it. So the grain collapses before it wants to be cut. So I want to talk about how we made this joint, which we talked about. This is the slip joint. It's a form of mortise and tenon. This is how it goes together. Here's our mortise. Here's our tenon. It slides in like that. Now, one of the hardest things for people to comprehend when I'm discussing this is that you want, in both directions, you want the side grain to be proud of the end grain. So in this direction, the tenon piece is proud. This direction, the mortise piece is proud. So the end grain is recessed here. The end grain is recessed here. The reason for that is when you come to the end of the process and you want to glue this up, the clamps will push on and will push on the side grain and make sure that the joint is tight. If they're flush and the clamps hit the end grain of this piece, it may be tight, but this could be open right here. So that's how you get a perfect glue up at the end. So this has to be thought of in the beginning of the process. So one of the ways to do mortise and tenon is with the bandsaw. This is great for use if you're doing really small frames, or if you don't have a tenoning jig for your table saw. The other reason for doing it this way is that it's much less intimidating for the beginner. That said, in order to do this, you have to have a bandsaw that's set up really well, really correctly. And the blade has to have no flex in it. The guides have to be adjusted correctly. The fence has to be 90 degrees to the table. The fence also has to be parallel to the blade. And all those things coming together are going to give you good joinery. So this is a stop block, and I put that there. The way that this is done is when I turn on the saw, I push in, and now this needs to be set over slightly. In this case, I'm not doing a joint right now, I'm just showing you how to set it up. And the stop block keeps me from going in too far. You flip it over and cut the other part of the mortise. And then what you have are two bandsaw curves that go in and stop. And the way to clean that out is by you do all your pieces at this setting, and then you bump the fence over slightly, and take off a little bit more, bump the fence over, going towards the center. That's how you remove the waste. This doesn't give you a flat bottom and your mortise here. So if this is for a cabinet back, that's fine. If it's for a cabinet door, you're going to have to clean that up with a chisel to get a perfect joint. Then we go, and we'll be going to the table saw. We go to the table saw to cut the shoulders. Then we come back here and cut off what are called the cheeks. And that's done in the same operation. And the cheek falls to the outside. You want to make sure that the cheek falls out to the outside. If you cut it off on the inside, then you're stuck with a bunch of pieces of wood that are in there that you have to reach in, and you have to turn the saw off and reach in and grab them. So right now I'm going to talk about this tenoning jig, which I bought. It's a Woodtech tenoning jig, which is actually a knockoff of the Delta tenoning jig. These are really relatively inexpensive for what they are. It's a lot of machine that goes into this. This is a great tool for this operation. It fits into the miter gauge slot on your table saw and slides back and forth. It's adjustable for angles in both directions if you're doing angled joinery. The nice thing about this is it has micro adjustments. So you take your piece of wood. Now the first thing I'm going to do is I'm going to make sure my table saw blade is 90 degrees to the table. Okay. The other thing is you want to make sure that you've got a table saw blade that has a raker tooth. And a raker tooth is a flat top tooth. If you look at your table saw blades, one tooth will go left, one will go right, and if there's a raker tooth, it'll be flat. If you don't use a raker tooth, you end up with tenons that have a little nub at the top. Okay, I mean mortises, excuse me. So first the raker tooth, you want to make sure your blade's really, really sharp and clean. One of the things that can really interrupt this process is if there's a lot of resin on the blade. And the resin on the blade causes the blade to behave as if it's dull. The way to get the resin off the blade is with oven cleaner. So Easy Off oven cleaner. They have stuff you can buy that's for cleaning blades, but the oven cleaner works just fine. Spray it on, let it sit, toothbrush the gunk off, and then you're good to go. So then we set the blade height. And the way that we decide the blade height is, if you remember earlier I said you want the end grain to be slightly recessed in the joint. So the blade height is set so the blade is slightly lower than the size of the piece that I'm mating to. So in this case, all my pieces are the same size. So that's my depth of my mortise allows the tenon to be to not go all the way through. Okay. Once that's done, then we put our piece in, and this will be with one of our test pieces. We slide up to the blade, and I usually with a pencil will mark just somewhere a center mark. What you want to do when you're doing a mortise and tenon is you want the mortise in this case to be slightly more than 1/3 the thickness of the joint. And I set the blade up at that point, and when you lock your piece in here, then you can unlock the tenoning jig, and sorry you can't see this from the camera over there, but you lock this table and there's a micro adjustment that'll move this back and forth incrementally, and then you lock it down so you can get perfect adjustments. And then you go ahead and cut your joint and you flip it around, cut it in the other direction, and that gives you your mortise. And with the table saw you get a perfectly clean bottom here. You don't have to chisel it at all afterwards. So once you have your mortises cut, you're going to be fitting your tenons. And this is where the test pieces come in. I take my test piece and I place it over my mortise, and I just make a pencil mark that is going to be the size of my tenon. Then I use those pencil marks to set the height of the blade. Once the blade height is set, using my miter gauge, and you're making sure that this miter gauge is set 90 degrees to the blade, I'm going to cut just the very tip of the piece of wood. What you're looking for is being able to slide your piece on and then let go and have it not fall out. So at this point it's too loose. Well, it's just right about there. So I can make that just a tiny bit lower. I just turned the dial 5 degrees. You want it to be tight enough that it won't fall out, but not so tight that it spreads the mortise. Once we've cut the end and gotten our height set up, we want to set up how far in the shoulders are going to be. So I'm bringing the fence over. I'm setting it up in such a way that we get the same end grain recessed in the other direction. So I'm setting the fence up so much so that the shoulders give me a tenon that's not quite as deep as the width of my mating piece. I'm just bringing the fence over, and I'm actually, with my piece, I'm obscuring the whole blade. I can't see any of the blade. I want this edge of the piece to be a 1/16 of an inch over from the edge of the blade. That way, when I cut my tenon, it won't be quite as long as the mating piece that it's meeting with. I take all my test pieces and I cut the ends. In fact, I cut the ends just like this on all my pieces. And the reason for that is if I'm going back to the bandsaw to finish the joint, that helps me set the blade on the bandsaw. One thing to look for is that your pieces, your shoulders line up all the way around. If they're not lining up with each other, something's amiss. Probably means that this is out of square or that your fence is not parallel to the blade. So this is very important that these shoulders line up with each other all the way around. Now at this point, I can go back to the bandsaw and set up to remove these cheeks, or I can use the table saw tenon jig. But if I can close that up and there's no step here. So I got lucky. I got that on the first try. It's not always that way. So I'll show you how to do this on the bandsaw, the other one. It's the same as when you're doing the mortise pretty much. You're going to be using the nubs, which I call these nubs, on the end to set. This is why I left them there. It helps you to set the saw up. So I'm setting it up just so that that passes just slightly behind the blade. And then I'll check and make sure that my stop block here is not allowing the bandsaw blade to travel into my nice shoulders I just made. I've had students that try to do the shoulders on the bandsaw and you never get great results. So the table saw is really crucial for that. So this is too tight. You can see that it's too tight. It's spreading the mortise. So I want to bump the fence over a little bit. The problem is I can't just go bump it over and take a little bit off. I need to use another test piece because the saw is going to cut differently on a fresh piece than it will just removing this. The blade's going to follow the path of least resistance, so I won't get an accurate measurement if I try to just take a little bit off of this one. I will in fact use this one to help me set it kind of where I want it. Then I go to the other test piece. As you can see, it behooves you to make plenty of extra test pieces so that you can get the perfect result. You can, if you have just a little bit that you have to clean up, you can use a chisel to fit it. I would stay away from sanding or filing.